But let me make sure. I think we're good. Okay. No microphone today, but that's fine. Okay. So we're up on YouTube. We're up on Instagram. Hope you guys are having a lovely start to your 2024. It is cold. I was just outside. It's snowing where I am. So, we have that. But today, it's funny that I was thinking about doing this topic for a while and it got to December and I was like, you know what? I know people get caught up in the weight loss portion of this, and this isn't directly tied to weight loss, but it is tied to metabolism, which is a big part of that. So I wanted to start today by going into metabolic health. And by the way, if you haven't signed up for the Becoming Invincible blog yet, this is all in written form on there. It's for free. You could sign up. The link's in my bio. I put it in my story on Instagram so you can check it out. But I'm going to be hitting kind of the major points, here now. So, okay, so let's just jump right into it. So first of all, we need to define what metabolism is. I think we hear a lot about it, like in general, but like, what does that actually mean? Metabolism is essentially the collection of all the reactions that occur in humans or any organisms. It's the entire suite of those biochemical processes. And what it does is help either change food or change sunlight or any other form of energy to break things down or build things up. Breaking down is called catabolism. Building up is called anabolism. That's why, in my realm, when I came up in sports, anabolic steroids were a problem because they were making people bigger. They built things up, right? Anabolic. Okay. So what metabolism is, in as simple a format as I can put it, is it is the sum total of all the reactions in the body. And those are going to either help build things up or break them down depending on the inputs. So we have things that are pro-metabolic, and pro doesn't mean growing. It just means supports healthy metabolism. Then we have anti-metabolic, things that harm healthy metabolism. It's not simple. So where this needs to start when it comes to metabolism is a little bit of the story about how it was discovered. So we actually didn't get a general idea of cellular respiration. It was kind of the Krebs cycle was in kind of the mid 1900s. It kind of, what most people learn today, what I learned in school, was from basically Peter Mitchell, who was, I think, won a Nobel Prize in like the 70s. And basically, that's the biochemistry that we know today, and what is taught in your biology class in high school, in college, in medical schools, any sort of health curriculum. That at least that's a Western curriculum, I should say. They're taught kind of these biochemical pathways and what they learn. So there's some useful stuff in there. And there was some stuff along the way that was kind of either pushed to the side or didn't fit the narrative. And one of those folks was a guy named Dr. Otto Warburg in the 1920s. Now, Warburg is actually the guy who found that cellular respiration, what mitochondria do to create energy, he's the one who discovered that, hey, the energy production takes place in these things, what he called grana, which were eventually mitochondria. He also suspected that they used a heavy metal to create energy. And that heavy metal turned out to be iron, which is what transports oxygen in the form of heme and hemoglobin, right? So he actually figured those things out in the 1920s, which was really, really cool. So he figured out that that heme, which is a porphyrin, and if you remember, we talked about this a couple of weeks ago. Porphyrins are basically these ring-like structures that are able to capture energy, and usually they have some sort of metal ion in the middle. It's a nitrogen cage, so there's 4 nitrogens that attach to a metal, and it's usually in a ring-like structure. So in hemoglobin, in heme, it's iron. In plants, we talked about this before, they have a chlorophyll. It's a similar structure, except instead of that iron, there's magnesium. But other than that, they're more or less the same structure. One has a carbon tail. Chlorophylls tend to have a carbon tail. But outside of that, it's basically the same structure. You're just swapping out an iron for a magnesium in the case of plants. And that is what allows us to capture light that ultimately we turn into energy in a lot of different ways. Now, Warburg discovered something in the 20s because, and the reason this is important is because what do we use hemoglobin for, right? It's to transport oxygen so that cellular respiration, so that mitochondria can do what they do to create energy, to create water, and ultimately carbon dioxide that we give back to plants to continue the cycle, right? We all learned that in third grade. So what Warburg actually found, though, because there wasn't a lot known about cancer at the time, frankly, it wasn't nearly as common as it is today. So as it was becoming a bit more commonplace, if you will, he was doing some work in the field of cancer. And what he found actually was that tumor cells use considerably less oxygen compared to healthy ones. And this was actually surprising because he thought that because tumor cells are constantly growing and they're kind of unchecked, they would actually use more oxygen. Turns out they use less than healthy cells. So, and what he found was that if healthy cells were deprived of 35% of their normal oxygen intake, every single cell would turn cancerous. Now, what does that have to do with metabolism? Well, one of those things, if again, if you zoom out and go back to the first blog we did, photosynthesis and cellular respiration are mirrors, plants create oxygen that us animals use to breathe, land animals use to breathe. To make energy, we give off the CO2 the plants need to make the sugars and oxygen we need, and the cycle continues to repeat itself. So we are reversing photosynthesis as animals in the animal kingdom, land animals in the animal kingdom. When we don't have oxygen, it creates a scenario in the body where it's going to eventually lead to unchecked growth because what the cell sense is, oh crap, there isn't enough oxygen in order to survive longer or perpetuate. We need to grow essentially unchecked. So this was the theory that he had. Now, so what do cancerous cells do, right? Like if they're not going to use oxygen to create and perpetuate their own survival, how do they survive? What's going on? They tend to use glycolysis or anaerobic glycolysis or fermentation. Now, fermentation actually still exists in bacteria and fungi that don't use oxygen to survive. So those still exist today. What fermentation does is it takes sugars like glucose, turns them into acids like lactic acid or alcohols, and do it without oxygen to create more energy or ATP, right? Now, we call this inefficient, at least in the context of humans. And yes, sugar ferments. So that's an important point. So sugar does ferment, yes. But it's important that the body is always going to try to make glucose or something from it so that respiration can occur. So we actually have this process called gluconeogenesis, which is taking fats and actually creating glucose out of it. So whether you put them in or not, you're going to end up with glucose at some point. So the concept of starving cancer out with just fats is actually not necessarily plausible, but that's not what this is for, because we're talking about the oxygen part, because again, that is the more important part of this, is why are these cells switching? Why are they recognizing an environment that is oxygen deprived and then going into this fermentation state? That is the real question. It isn't a carbohydrate, fat, or protein question. It is a oxygen, electron, and proton question. It's more of a physics question. And that's why I think we haven't made a lot of progress, I should say, in the cancer space, basically since the 70s. So basically what Warburg found is that cancer cells get energy by fermentation, which is the same way fungi and many bacteria do. And effectively, unchecked glycolysis, unchecked fermentation means unchecked growth, which eventually leads to tumor growth. And what he found or what he even stated in multiple of his lectures, was that the causative factor of the origin of tumors is nothing other than oxygen deficiency. Now, at the time, this was very contentious. This is like the 1930s and stuff. And many scientists at the time just did not believe that the cause of cancer could be so simple. It can't just be a lack of oxygen, right? Like it can't be that simple. The reason being is at the time, they were finding that certain chemicals were associated with increasing cancer rates, either in lab mice or in certain areas, and more looking at epidemiological stuff. So they were like, no way, it can't be that simple. And what Warburg would say is like, yes, each of these thousands of chemicals is associated with an increased risk of cancer because they are impairing glycolysis or cellular respiration, which in modern language is just mitochondrial dysfunction. In other words, anything that is going to damage the mitochondria, anything that is going to damage the normal energy chain, energy metabolism in a cell, which is your mitochondria, that can potentially lead to cancer because of a depletion in oxygen in cells. Now, in 1942, there was another doctor, Dean Burke, who actually checked. He was basically trying to call Warburg out, and turns out that in over 95% of the tumors that he examined, what Warburg was saying was true. It was that no matter what chemicals you put in, it ultimately leads to a lower oxygen threshold in mitochondria. Those ones with the lower oxygen threshold, oxygen tension, whatever you want to use for it, initiated cancer growth. So faulty metabolism because of a lack of oxygen, I shouldn't even say faulty metabolism, a lack of oxygen shifts metabolism in these cells towards cancer growth. So that is ultimately what he found and why this is important. And I think that what Warburg was saying is right. Now, Warburg actually passed away in 1970. 1970 happened to be the year the first oncogene was discovered. Now, onco prefix, it means cancerous or relating to cancers, tumors, etc. Oncogene, right? Oncogene. So that was discovered in 1970. And basically since 1970 up until right now, we're talking 54 years later, the concept that cancer is genetic or it's passed down from mom and dad because mom had breast cancer or dad had prostate cancer or lung cancer or whatever, and now you're at a greater risk, is still what most people believe today, even though the logic is faulty, and there's multiple reasons for it. The first is that with the invention of the PET scan, what PET scans do is you're able to track certain radioactive substances in the body. So what they would do is they would give people radioactive forms of glucose. They would ingest it. And what they found was that the areas of the body that were using the glucose faster were the cancerous parts. And why was this happening? Because these cells do not use oxygen efficiently, so they need more glucose at a faster rate. So they found that the areas of the body that had tumors were oxygen depleted environments, and they actually were able to confirm what Warburg found using PET scans, which you can use today. So and we know that if you even look at the National Cancer Institute in the US, they will say that no more than 10% of all cancers can possibly be genetic. And if you look outside of the US, they'll say it's even lower than 5%. And this is known. This is on, .org websites or .gov websites. These aren't, this isn't some sort of like conspiracy theory or anything like that. And the point is, this notion that cancers are genetic or they're passed down is just simply not true. We're looking at DNA genetic problems when these are mitochondrial problems, metabolism problems that the environment we put ourselves in lead us to. And unfortunately, Warburg ended up being in the minority at the time. And then basically since his death, this notion that it's genetic has just become popularized when it's simply not true. And we have modern technologies now that confirm that he was correct. So, we need to kind of keep that in mind. And what became clear is that a relative lack of oxygen is what creates an environment for cancer cells to thrive. Now, why does that happen? When you are low on oxygen, that what we use, the recycling ability of the body, is we use two different forms of recycling, if you will. We have autophagy, which is essentially taking, parts of cells, the organelles that are not necessarily working well, break them down into pieces, and then recycle the parts that are usable. And then apoptosis, which you might hear as programmed cell death, but basically it's taking cells that are either broken or not working properly or at the end of their life cycle and breaking them down, and then again getting what you can from the situation. If there's any usable parts, you take them and recycle that using autophagy. So they kind of go hand in hand, the apoptosis and autophagy part of it. But what happens in a low oxygen environment, these mechanisms are effectively kind of shut off because the situation is so oxygen starved that in those cells, they're like, no, we need to continue to replicate to survive. It's a survival mechanism. Cancer is just a survival mechanism given the environment. So that's a major, major part of it. Now there's a light part that comes into this too. So if you don't mention, a few weeks ago, we talked about Fritz Pop. So Fritz Pop is one of the really trailblazers, if you will, on biophoton research, these ultra weak, what they call ultra weak, usually ELFs, extremely low frequency UV light emissions that take place in cells in mitochondria. These things happen in all mitochondria. They release light. So each one of our cells, even though we cannot see it, especially because it's in the UV spectrum, they are emitting light. This is how cells communicate. We've talked about this in other blogs. It can't just be random jostling of molecules and hoping one fits into the right area, and it can't be random. There needs to be a signaling pathway, and the way this is done is through light emissions. What Fritz Pop found, especially when it comes to cancer and metabolism, is that cancer cells tended to have greater biophoton emissions than healthy models, I should say, healthy models. And he was using this in mice. So basically, the more light this was emitting is a sign around to the surrounding environment. Hey, something's going wrong. We need help here. So it's the same thing if you get an injury. What happens, like when you do that, is you want to bring inflammatory factors in an injury. You want to bring in neutrophils and macrophages and mast cells and all these things, because you need to call them there. The light signal is part of what does that. When things are going well, you're not going to release as much light because things are normal. It's like the alarm going off, right? So it's literally like setting an alarm off. You don't want an alarm going off all the time because that's not going to lead to a great outcome. You want the alarm to go off when you need it. Hey, there's something happened. There's an injury. There's something going on that needs a response. So we're going to literally flash the light to say, hey, we need more help here. So where does the mitochondria come into this? So as you mentioned, like there is with this, it's basically what's going on with cancer is there is some sort of hiccup in mitochondria metabolism. There's some sort of hiccup with it. It's slowed down. It's not getting enough oxygen for whatever reason. It's not producing the water and ATP we need for it to continue to flow. And if that's not happening, that can lead to problems down the road. Now, there's this concept known as heteroplasmy. Now, heteroplasmy means changes, variants in mitochondria within cells. So generally speaking, you could have up to 70% heteroplasmy rate and still have healthy cell function. But if the mitochondria are consistently changing and there's more variance, and what's up, what's going on, it can lead to a lot of the chronic challenges we see today. We talk about cancer, but also heart disease, diabetes, kidney disease, autoimmune challenges. All of these things are a product of potentially heteroplasmy rate. And why would that happen? It's because of the environment that is incorrect, causing a shift in mitochondria, causing a shift in their function, their either ability to not push electrons through the electron transport chain to make energy, or just simply not getting enough oxygen in the first place. And once you know one or two of those, or which one of those it is, or what the underlying causes are, then you could start getting to some real answers. Now, what are some of those things? We're going to go through some of those things that can potentially cause some of those problems. But the light part of it is really important too, as we're kind of talking about, because that is going to ultimately be the trigger, either directly from sunlight, which is why I keep talking about getting outside, when you can, even in the winter when it's snowing like it is today, or from your food. Now, what is food other than a manifestation of sunlight, just in a different form, right? Because it literally takes photons from light, is transformed, in the case of plants, because that's where this all starts, into sugars, but it's just converted light energy, water, oxygen. All of this is converted light energy. So it's either taking electrons directly from the sun, directly from the ground, directly from light, or indirectly through the food we eat. And how well those protons are passed, how well you are utilizing oxygen through proper breathing patterns, which is why, I talk about breath work on these calls so much. It's nasal breathing is the foundation. If you're not nasally breathing, that is something you need to teach yourself how to do, or reteach yourself how to do. And it can happen whether, you've had an injury or something like that. But it's getting the oxygen you need so that you can create a healthy oxygen saturation, a higher oxygen tension, so that you can maintain healthy metabolism. Because when you start depleting oxygen, when you start depleting electrons from healthier food sources, or from light, or from how you're breathing, that's when you start seeing these chronic challenges come in. And it starts down at the mitochondrial level, which is what metabolism really is. It might look like weight gain. It might look like blood sugar imbalance. It might look like joint pain. It might look like cancer for some people. But mitochondrial dysfunction, depending on the tissues they're in, are going to affect tissues a different way. But either way, the roots are all the same, and it is really just a lack of oxygen that causes the issue. So now that we know that, how do we optimize it? How do we bring our metabolism back online? So that's what I want to spend the next 15, 20 minutes, doing, is talking about some actionable stuff. The first is you want to filter out any excess lactic acid, particularly if, you're already having trouble with energy. So fatigue, it could be underlying gut issues. It could be something like that. It could be a lack of CO2, which is going to come from, again, mouth breathing, drooling, sleep apnea, not nasally breathing. So one way to filter out excess lactic acid is to start nasally breathing when you're at rest. And basically you should be, if you don't know at this point, you should be nasally breathing at all times, with the exception maybe of like exercise, moderate to intense exercise. So even through, walking or other mild forms of exercise, you should be able to breathe exclusively through your nose. And if that's something you struggle with, this is something you can retrain yourself. I have a course on it. You can check it out. It's called the Breathe Easy Masterclass. Other things you might want to avoid in the short term to not get excess lactic acid in your system might be fermented foods for a short time, because how most of the foods that we eat that are fermented, it's due to the production of lactic acid, right? Because these bacteria use lactic acid to ferment. That's how they create their own ATP to get what they need done. What I will say though is the lactic acid that's produced during exercise generally isn't as much of an issue, provided unless you're overtraining. But generally speaking, that's not going to be the case for most people. Um, it's really a lot. It's undertraining or a breathing challenge. So I would certainly address one of those two first. And again, both of those are literally available to you for free. The second one that's really going to impair your ability to oxygenate your cells and tissues and mitochondria is actually poor quality fats, poor quality oils. So not all seed oils are the same. Not all seed oils are bad necessarily. For example, and we'll talk about one of those actually towards the end. But what I really mean by this is the processed seed and vegetable oils that are hyper-inflammatory, or the ones that undergo high temperature heating, that are oxidized, that are processed using things like hexane and other chemicals, and are superheated to supposedly sterilize them. That are petroleum based. So I don't think most people realize like that a lot of these conventional oils were not meant to be foods at any point. They were actually meant to be used for cars and things of that nature, and are petroleum based. And the reason why most of the pharmaceutical injury and a lot of this stuff is petroleum based goes back to Rockefeller, but that's a story for another day, but not today. All of these things that they lead to the production of reactive oxygen species and free radicals. Now, they're not inherently bad, reactive oxygen species and free radicals, but if you have a lot of them, particularly exogenous ones from food-like substances, like these fake foods that are superheated and oxidized, they're going to deplete all your antioxidants. Whatever your antioxidants, they're your vitamins A, C, and E, your selenium, your zinc, your magnesium. And sure, while eating foods that have those are the best option, and sometimes taking supplements with those can be helpful. If you work with me, like I'm generally not as much a fan of that versus just getting this stuff out. That is going to be more effective. And you can take antioxidants from now until the cows come home. If you're constantly consuming this stuff, you are not going to fix the problem. And you can overdo it with exogenous antioxidants too, because there's a balance between them and reactive oxygen species. Like most things in life, if it is living, it is a balance. Nothing is static. The only time you actually reach true equilibrium is death. There's always moving. There's always electric flow. When the electric flow stops, that's death. So we don't want that, right? What these poor quality fats do, and I don't think most people realize this, the poor quality fats actually are a more significant contributor to diabetes than sugar itself. And it's because they destroy the mitochondria, particularly that use carbohydrates for energy. It actually destroys the processing of carbohydrates because you're building membranes that are made of garbage, right? The fats you bring in build all our cellular mitochondrial membranes. So if you're bringing in those garbage membranes, they're actually going to impair your ability to break down other foods. So, and that's why, again, we have to talk about it in this way. We can't look at it such a myopic thing like, oh, there's diabetes, you must avoid sugar. Oh, you're putting on fat, you have to have no fats anymore, or whatever diet guru, whatever's going to tell you. It's no, there's some sort of dysfunctional process. There's some process that's not working as well as it should because the environment is dictating this is best right now, given the inputs. So once you change the inputs, you can start to make a difference. One of those things is going to be these poor quality fats. So definitely want to get rid of those oils. Whole fats are generally going to be better sources than oils. So I always prefer whole olives or coconuts versus, say, olive oil or coconut oil. They certainly have a place, I think, in small amounts. But I would much prefer you eat the whole fruit, the olive, the coconut, avocado, etc. You want to make sure you're getting your healthy sources of fats, your fat soluble vitamins, right? Those are vitamins A, C, E, and K. Not A, D, E, and K. C. I was saying C because I was going to say sun. A, D, E, and K. D, your best source of that is going to be what? Sunlight. We'll talk about that in a minute. Sauna sessions. I think one of the big things, especially in the modern environment, you're getting so much blue light. Balancing that with red infrared is really important. Best way to do that, again, is sunlight. But if you're in a winter place like me, you can take advantage of infrared, which we interpret infrared as heat. So we can't see infrared, but we perceive it as heat. So the heat we feel from the sun in the summer, or even now in the cold, that's actually infrared heat. That's infrared wavelengths, I should say. Bee pollen could be helpful. If you have a body fat of over, say, like 14, 15% for men or 17, 18% for women, start slowly bringing that down with some of the stuff we're talking about, because excess fat tissue tends to be a place to store toxins, particularly things like heavy metals, neurological things. They tend to get stored away in fat if you can't process them in time. So that's one. Heavy metals. I'm not going to spend too much time on this because, again, I actually do have a whole course on this, but I want to touch on the big ones because I have a lot to go through still. So the big ones: lead, cadmium, arsenic, mercury. Some people will say aluminum, although aluminum is technically not a heavy metal if you go by the strict definition of heavy metals, but let's include aluminum for today. So let's go through them. Lead, it's a well-established neurotoxin. It's associated with things like reduced IQ, anxiety disorders, depression. It's going to mess up your mitochondrial redox system. It's going to soak up a lot of those antioxidants, so you can't use them in other ways. So that's not good. So, avoiding lead as much as you can is, generally speaking, a good idea. Cadmium tends to damage the lungs, kidneys, things of that nature. Most common source of cadmium are conventional grains and tobacco. So that's the easiest way to avoid them, right? Is to not consume those. Aluminum. I know I touched on this. Technically, it's not a heavy metal because it's not 5 times the specific gravity of water. Aluminum is not good. Problem is, it's everywhere. It's a known neurotoxin. It can cross the blood-brain barrier. It causes oxidative stress. Oxidative stress, we've already talked about, linked to neurodegeneration. Why is this a problem? Aluminum crosses the blood-brain barrier. The mitochondria in brain cells are then affected. They don't utilize oxygen as well. The brain starts to not function as well because of that. And it's not because you're deteriorating or you're getting old. It's because of a toxicity, and the body's doing its best to just kind of hold on to what it has. But it's always, always, always striving towards healing, striving towards regeneration. If we constantly hammer it with the stuff we don't need, eventually that's going to cause issues. Other places where you can find aluminum, if you have any aluminum cookware, start, getting rid of that. I prefer using cast iron or ceramic. I like Extrema cookware. That's what I use for ceramic, but I also use cast iron. Some stainless steels can be good. I would certainly look into them. It depends on the alloys they use. They're not all the same, so you kind of have to do some homework on that. But for sure, cast iron, ceramic, I would say would be the way to go. I would also check out any, cosmetic or self-care products. So deodorants, shampoos, toothpastes. Some of these can contain aluminum. So if they do, you want to swap them out. There's a lot of things nowadays that you can find aluminum-free alternatives for. So that's not too difficult to find usually. Okay, arsenic. So arsenic is linked to a bunch of different cancers: lung, bladder, skin. Again, where's arsenic mostly found? In unfiltered water, certain seafoods, conventional rice. That's usually going to be where, arsenic's mostly from. You can get most of the arsenic off of organic rice by simply just rinsing it, soaking it overnight. So if today's Friday, if I want to make rice tomorrow, I'll soak it tonight, strain out the water, give it another rinse, and then cook it. So And you can do that with, room temperature water, cold water. I wouldn't use hot water, but you can do that. Mercury. There's really not much to say here. It's another one that crosses the blood-brain barrier. If you have mercury amalgam fillings or you have a dentist that says they're fine, I would say it's time to find a new dentist. It is a well-known neurotoxin. It destroys the brain. You do not want, and nervous system in general. If you have neurological, or I should say neurodegenerative compounds in your body like mercury, that is generally speaking not going to be good for you over the long term. The other one I want to talk about is iron. So iron, of course, is not toxic on its own. But too much iron also isn't good. Like any mineral, it needs to be in a balance. Too much or too little is not good. And what I find is actually most folks who are anemic don't necessarily, it's not an iron intake issue. It tends to be a digestive issue. It's either poor absorption or poor digestion. And if there's an underlying gut issue, then we need to fix that. Other things that are involved with healthy iron metabolism: vitamin A again, sunlight, vitamin D, biotin, vitamin C. So making sure you're getting either foods or environmental sources of these things are really useful if you want healthy iron metabolism. So, iron isn't necessarily bad. What I find, most people who are iron deficient or anemic, it's not an outright, I'm not consuming enough iron. It's an underlying digestive issue or an iron metabolism issue that needs to be addressed. So sometimes just supplementing with iron, again, does not fix the underlying issues. Estrogens. Okay, so underlying excess estrogens, these are everywhere. These are your parabens, they're phthalates. Any sort of sex hormone imbalance is going to cause long-term problems. Excess estrogens, for example, can inhibit thyroid hormone function, elevate nitric oxide. You don't want too much of that either. We'll talk about that. Encourage the retention of iron, damage the adrenals, histamine release issues, increased risks of infertility, of miscarriages, imbalances with testosterone and progesterone, which is important for both men and women. Is carcinogenic, especially if you're getting it again from these kind of excess sources: the plastics, the self-care products, the poor quality fats, the cosmetics, the conventional foods because of the pesticides. I mean, there's so many ways, and it's just doing what you can to limit these exposures as much as possible. Too much nitric oxide. So actually, nitric oxide is useful. And again, I talk about this in my breathwork course, but it's actually a reactive oxygen species in its own right. Now, again, that's not necessarily a bad thing. I talked about it in another blog. I'll link it in this blog. But too much nitric oxide can also accelerate aging because it impairs mitochondrial function. So actually, too much too much nitric oxide slows down cytochrome C oxidase. So if you look at, it's step 4, I would say, in the electron transport chain. Infrared light actually increases it. Nitric oxide decreases it. So again, what we talk about, it's not utilizing oxygen as well. That's going to lead to cells that are not performing at their best. So too much nitric oxide could slow that down. Now, the reason you would have too much nitric oxide are usually due to things like, if you're a man, erectile dysfunction drugs or supplements, because usually that's what they'll work on. Pre-workouts, which I tell all people to avoid. I think most of them are absolute garbage. Not enough antioxidants, not enough sulfur-containing foods. If there's underlying gut problems, if you're drinking tap water, lack of sunlight, mouth breathing, as I just talked about, artificial light at night, estrogen dominance can certainly do it too. So, all of those things are going to lead to potentially too much nitric oxide. If you want to get an optimal amount of nitric oxide, you're basically doing the opposite of that. You want to get sunlight on your skin, in your eyes, your bare eyes, every day. If you want to address any underlying gut issues, if you're not nasally breathing during the day and at night, address it. You want to reduce artificial light at night. You want to remove or eliminate any of the excess estrogens that we talked about, the xenoestrogens. If you do not have a water filter, I highly recommend getting a water filter. You do want one at least that can filter out fluoride. That's big. And again, don't use if you have an issue with ED or do not have the energy to get up for a workout, figure out why and fix it instead of relying on something that can cause downstream issues. Stress can certainly do it as well. I'm not going to spend too much time on this, but what you need to know is that too much stress, high levels of cortisol for a long period of time are going to impair mitochondrial function and your ability to utilize oxygen as well as you should. Thyroid hormones are also a big one. Now, the thyroid, as I've talked about, is effectively the gas pedal of the body. This is what turns metabolism up or down. So you need healthy thyroid function for optimal sex hormones, for like testosterone, estrogen, DHT, progesterone, etc. Effectively, if the adrenals are overworking, the thyroid's generally kind of turned off. And if you're in more of a parasympathetic state, the thyroid kind of kicks in. So it's usually kind of one or the other. They're not both going to be high or both going to be low in most cases. It's usually if the adrenals are rocking, the thyroid's slow. And as you get out of that stress state, the thyroid kicks back in. So the biggest issue here with thyroid hormones is the fluoride part. Fluoride is the most electronegative atom that we're aware of, which means it will outcompete iodine in a lot of reactions because it is more electronegative. It is more willing to bind to a lot of those things that iodine would. Sometimes iodine could help because, again, if you take this Newtonian perspective, you can essentially flood out the fluoride, so to speak, by just throwing more on it. But again, what I find with most people is that it's not necessarily an iodine deficiency. It can look like one, but it's actually just effectively fluoride poisoning. That's the shorthand way to put it, because they compete for the same receptors. So again, making sure you're getting a water filter that at minimum can filter out fluoride is really important. Again, this is a well-known neurotoxin. Nazi scientists use this on people in the concentration camps because they thought it would make people more docile. And now it's in the water supply, and it's, again, a well-known neurotoxin. And it's linked to cardiovascular, central nervous system issues, digestive issues, hormone issues, immune system dysfunction, renal dysfunction, respiratory system issues, and a lot of different neurological issues too, infertility. All these are related to fluoride effectively poisoning, even though it's in your tap water. I don't know what else to say. I have a couple systems at the moment. I actually have a clearly filtered system that I like. I also have an AquaTrue system, which is a reverse osmosis system. Berkey's also good. Those are kind of the three, I would say, good, most popular ones. Although Berkey's kind of going through a rebranding right now, so it's not called Berkey, I don't think, anymore. The name's escaping me, but it'll come, or I'll look it up after this. But I mean, the best option really is to get like a full house filtration system, or you have access to a healthy version of spring water, a healthy spring. Those are probably the best options, but obviously not everyone has that ability. So just for context, we use the other systems like AquaTrue and Clearly Filter because we don't have a permanent living residence. We've rented a lot of places where we live. But if you're in, say, like a permanent home, I would say looking into investing in a full house filtration system is probably worth the investment if you're going to be there, 20, 30, 40 years or something like that. So that would be what I would do. Sunlight, you need it. We talked about the infrared benefits, the balancing of the blue light with the red. The sunlight is the single most important nutrient on the planet. I've done entire blogs on it. I'm not going to waste too much time here. You could read it or go back to the videos I did on them. But it's that important. Certain B vitamins you actually need for healthy metabolism. Now, this is a gross oversimplification, but certain B vitamins are more associated with energy production, metabolism. So B1, thiamine, riboflavin, niacin, pantothenic acid, that's B1, 2, 3, and 5, are primarily your B vitamins that are associated with energy production. So you can look for foods that are rich in those. I've put lists in the blog post. I don't want to like just read them out. You could go check out the blog. But that would be, those are good. Those are going to give you sources to do that. So replenishing those on a regular basis is probably a good idea. Carbohydrates. So you want to consume carbohydrates. These are good for you. Again, we talked about the photosynthetic cellular respiration cycle that we are a part of. Consuming plant carbohydrates from real foods is literally light energy. We use that light energy for these things to function as properly as we can. So if you're sticking to carbohydrates that come directly from nature, you're going to be in good shape with time. Now, if you're carb intolerant or have some issues digesting carbs, there is likely an underlying pancreas or digestive tract weakness that you need to fix. This is why people feel better on carnivore diets or all meat or no animal product diets for no plant products, I should say, for a short period of time. It's because there's actually underlying gut issues that aren't fixed. And once you fix those, you should be able to get these in. So you might have to work slow. You might have to start with just cooked foods. You know, there's ways to break this back in, but avoiding it and avoiding symptoms might make you feel better, but it's not going to fix the problem. Talked about the fat soluble vitamins already, talked about the breath work already. So the last thing I want to talk about on this list is actually black seed oil. Nigella sativa, my favorite. Mentioned in the Torah, the Bible, Quran, you know, if you're religious at all, pretty cool. It's mentioned in all those religious texts. Black seed oil actually helps recycle NAD and NADH. So in other words, these are the electron transporter, or the things that bring electrons to the electron transport chain. So, you know, these bring the hydrogens you need for that cycle to run. Now, black seed oil is one of my favorites for a variety of reasons. I've used it with a bunch of folks. I like Black Cumin Seed Forte by MediHerb. I like the organic black seed oil by Heritage. There's caps by Gaia Herbs that are good too. Those are all, you can find those on my online dispensary on my full script. That's linked somewhere if you want to check that out. Now, really quick, because I got 5 minutes before I got to go. But yeah, like the bottom line is your metabolism is going to be a sum total of the electrons we bring into the system and our ability to utilize oxygen effectively. And this is all comes down to what we eat, drink, think, breathe, put on our skin, and who we communicate with. If you are controlling for those and optimizing those, you're going to be in good shape. And so much of this starts with just the relentless fundamentals, day in, day out. And it doesn't cost you an arm and a leg to do it. You don't need to do another cleanse and detox and all that. And I certainly help people with that and can help. But the truth is, it comes down to the day in, day out stuff. And that's what makes the difference. Now, before I go quickly, like, this is the first week of 2024. It's an exciting time. I think it's going to be a great year. I recently have opened up some slots to work with me directly. If you want a guide to help you input this, to cut out all the noise that you see here on social media, and looking for someone who's in your corner and is not going to leave you hanging or bail on you, and you really want a coach. Like, sure, I have the background as a doctor and doing all that, but it's really coaching people. And you're looking for a guide and a partner so you can bounce these ideas off of, so that you can not get caught up. And I do believe that this year that roughly half of the content that you will see on platforms like this will be AI driven and generated. So even some of the people you follow right now are going to resort to these things that are not human, trying to make a buck or do whatever they're trying to do. We need to get back to humanity and nature primarily. And the further we are deviating from that, the worse our health is getting. So if you want to schedule a call with me and you're looking for a partner to help guide you for and be in your corner for a while, right now I'm working with folks for up to 6 months at a time. And so I will be with you through the process to help build this foundation for your life as it pertains to you. Then let's set up a call. Let's talk. And so you can get your life back. You can get out of the pain. You cannot rely on a system that is so clearly broken. And, we could get back to where we need to be. So thank you for tuning in. I hope you guys have a wonderful first weekend of 2024. I'll see you next week. Okay.